5.4, question 1. For a binomial experiment, what probability distribution is used to find the probability that the first success will occur on a specific trial? All right, that's the that is the geometric. All right, so do we have geometric over here? We do, right there. That's the geometric. Let's claim that one. Question 2. Given a binomial experiment with probability success on a single trial being 0.4, find the probability that the first success occurs on trial number 3. Now, there's a formula for this, but it's probably easier if we just look at it this way. Just write it out. What do you think's got to happen here? All right, you want trial number 3, the first success. So you need what? A failure, and a success. So we need a failure, and a success. Now, the probability of a success is 0.4. What's the probability of a failure? 0.60. Another failure, 0.60. And then you want the success right here. So we'll just multiply those together, right? So just multiply these. I got 0.144, and it says round to 3 decimal places. Well, that's exactly where we are. So how about 0.144? So that would happen about 14.5% of the time. And number 3, given a binomial experiment with n equal to 100, so 100 trials, and the probability of success on a single trial is 0.03, very small. Find the value of lambda. Now lambda, what they're talking about here, this is a Poisson distribution because you've got a binomial experiment, but the probability of success is very small. So we're going to use the Poisson distribution. Find the value of lambda. Now lambda is the expected number. Now for a Poisson distribution, I'll write it down here. Here's what we have. Lambda, the expected number, is equal to n times p. After all, it is binomial. So what we're going to have here in binomial, that's the expected number. So this is 100 times 0.03. So we would expect 3 successes. All right, so we need to put that in here. Get lambda. I'm thinking it's 3. And we have a formula for computing Poisson probabilities. It is this one here. It says the probability of getting exactly r successes is e to the negative lambda, we just found lambda, times lambda to r, the number of successes that you want, divided by r factorial, the number of successes that you want factorial. Let's do it 2 ways, by pencil and by calculator. So by pencil, we're going to be computing this. We're going to have e to the negative, now lambda was 3, times 3 to the 3 successes. Oh, that's interesting. All right, all over number of successes factorial. Now when I computed that, I got 0.224, and we're supposed to round to 4 decimal places, 2240. All right, so I'm going to report this one now as 0.2240. Now here's how I computed that. I want, first of all, this e to the negative 3. All right, so that e to the negative 3. Here's what you need to do. You're going to press the second key. And then in the very first column, a little bit more than halfway down, you're going to see a key that says LN. All right, so you see a key that says LN. And above it, it says e to the x. You press that key, and what comes up is e, and then there's a box up here waiting for your exponent. Put in negative. All right, now be careful. It's not minus. It's negative, and then you put in the 3. All right? E to the negative 3. That will give you this part right here. Then you have to be careful here because of the way the calculator is set up. It stays in the exponent. So what you want to do is to get yourself out of the exponent. So arrow over. Use your arrow key. All right, so you put in, I'll do it too, negative 3. Use your arrow key, get out of the exponent. Sends you back down here. Now, press times. And then you want 3 to the 3. So just put 3 and then caret 3. Now the caret is right above the division sign. Then divide and then put 3. Now 3 factorial you can probably do, but if it was a big number, you'd put in 3. Go to math. Now math key is in the very first column, about the third one down. And then over to PRB. and select item 4, right? And that's the factorial. Okay, then press enter, and that number should come up. All right, that's how to do it by hand. Now let's do it by calculator. So by calculator, press second VARS, right, because it's a distribution, so we're going to go get one of our probability distributions. So second VARS, now scroll down to C. C says Poisson PDF. Now we're using P because we have precisely one number here. We're not looking for a collection of numbers, just PDF. All right, so you select Poisson PDF, and then you get lambda, right? Now we have to put in lambda. Our lambda is 3, so put in a 3. Press enter. Then it says the X value. Now the X value for us just happens to be 3. A lot of 3's in this problem. So you put in 3 there. Then you paste. All right, so just, arrow down to paste and press enter. And then what comes up, you can't see the whole thing, but it's Poisson PDF, and then it tells you 3, 3. Okay? And now press enter. And you press enter, and what comes up is that 2240. Okay, there we go.